What's up, class? In this video we are reviewing our study guide for Standard 11. Going through the multiple choice questions in the given diagram, which of the following statements is not true? Okay, so the reason why the answer is B is because that says angle ADE is congruent to angle AED. We have no evidence that those two angles are congruent. In the next problem, which of the following would not solve for the correct value of x? The reason why the answer here is D is because we have to set up a correct, consistent comparison, but x plus 6 compared to 10 is 6 compared to 4. So that is clearly, as I mark that out, not a consistent comparison. For number 3, the geometric mean of 10 and 40 is, so to find geometric mean, we're multiplying those two numbers together, and then we're square rooting, rather than adding and dividing by 2 for the arithmetic mean. So when we do that, we get the square root of 400, which is 20. In the next problem, if g is the geometric mean of a and b, then which of the following is not true? The reason why the answer here is A is because you would have a geometric mean if you have a pattern of a same number in the means space there. So A and B would be the extremes if I look at this case. Or in this case, G would be the means and A and B would be the extremes. Or for answer C, if we square root that, then G, the geometric mean, is the square root of A times B, which is the geometric mean. So our answer is A. For number 5, which of the following statements is not true? We have no evidence that triangle ADB multiplied by 2 would equal triangle BDC. So therefore, that's the statement that's not true. For question 6, we're looking for the value of x. So what we have is that we have these base angles are equal, which makes it an isosceles right triangle. Here's our value x. So to find x, that means that this has to be a 45, 45, 90 triangle. So to go from the long to the short side, we have to divide by the square root of 2. So 12 radical 6 divide by square root of 2, we're going to have 12 radical 3, so that is C. For number 7, the value of x is, so for this problem, we would have to, we're given the medium, so medium to short, we're dividing by the square root of 3, and then the long would be multiplied by 2, so that would be 18 over the square root of 3, since this is our 30, 60, 90 triangle. So 18 divided by the square root of 3. What answer is the same as that? That answer is B, because both of those answers are approximately 10.4. If we were to convert them to decimals, then we could recognize what answer is correct. The next question says the ratio of the medium side to the short side in a 30-degree right triangle. Okay, so that assumes that it's a 30, 60, 90 degree right triangle. The ratio of medium to short would be radical 3 compared to 1. So our answer is D. Number 9, which of the following is equal to the cosine of 35? The key here is that the cosine of the angle plus the sine of the angle has to add up to 90 degrees. They have to be complementary. So if the cosine is 35, then the sine would have to be 55. That's because 35 plus the 55 is 90. So for number 10, if the cosine of angle theta is equal to the sine of angle beta, then the two angles must be complementary, meaning that both angles must add up to 90 degrees. 11 through 15 are true and false questions. So what we want to do for question 11 here is to solve both equations and see if x is the same for both of them. If it is, then the proportions are the same and it's true. So if I cross multiply, I would get 15x equals 30. So then dividing by 15, x equals 2. And the next problem, I would get 25x is distributing that 10 to both terms, 10x plus 30. So solving this further, subtract 10x to both sides. 15x is 30. So again, x is 2. So since x equals 2 to both of them, then the answer to this question is true. Number 12, the geometric mean of 6 and 8 is 7. So 6 times 8 square rooted is not going to equal 7, so that one is false. Number 13, in a right isosceles triangle, if one leg is 3 radical 2, then the hypotenuse is 6. To figure this out, let's draw out that right isosceles triangle. One of the legs is 3 radical 2. So to go from short to long, we have to multiply by radical 2. And you'd have 3 radical 2 times radical 2. So that becomes 3 times 2, which is 6. So the hypotenuse is in fact 6. Number 14, in the right isosceles triangle, if the hypotenuse is 14, then one leg is 7 radical 2. One way to check that would be if you multiply the leg by radical 2, then you would get 7 times 2, which is 14, so the hypotenuse would be 14. So that one is also true. 14 is also true. For number 15, if the cosine of angle theta is equal to the sine of beta, then beta equals 90 plus theta. The reason why that is false is because theta plus beta, adding up both of those angles, has to equal 90. So we can see that that equation is not true. In this question, we're finding the value of the missing variables. So this is the side splitter theorem, where we have to set up the split sides in consistent proportion. So one way to do 16, and there's multiple ways, but one way would be to say x over 3 is equal to x plus 1 over 4. When you cross multiply there, you would get 4x equals 3x plus 3. So subtracting 3x to both sides, you would get x equals 3. So that's your answer for the first one. For the second part, setting up a consistent proportion, one way would be to say that x plus 2 over 2 is equal to the split sides 10 over 2.5. So when we cross multiply, we'll get 2.5x plus 5 is equal to 20. So 2.5x is equal to 15. And dividing by 2.5, we get x equals 6. For the third problem, setting up a consistent proportion, one way to do it would be to say x over the whole 12 is equal to 3.5 over the whole 14. So then when you cross multiply, you would get 14x equals 12 times 3.5, which is 42. When you divide by 14, you'll get x equals 3. So the answer there is x equals 3. With these similar right triangles, there's multiple ways to set up these problems. But one way would be to say that 4 is to z as z is to the whole 12. So we can set up 4 is to z as z is to 12. If we solve that, we'll get z squared equals 4 times 12, which is 48. So when we square root both sides, we'll get z equals 6.9. Okay, so we get what z equals. Then with that 6.9, when we mark the diagram, a next step could be to find the y value. One way would be to say that if the entire distance is 12, then that distance is 8. So setting up a proportion, we could set up 8 is to y as y is to 4. 8 is to y as y is to 4. So then we get y squared equals 8 times 4, which is 32. So square rooting, we'll get y equals the square root of 32, which is 5.7. Finally, we could do Pythagorean theorem to get x. So 8 squared plus 5.7 squared equals x squared. When you solve for x using this equation, you should get 9.8. Going through the second question, we could set up the proportion 3 is to y as y is to 12. So short is to medium is short is to medium. 3 is to y as y is to 12. We get y squared equals 36. So square rooting y equals 6. So the y value is 6. Then we could use the Pythagorean theorem twice to find both x or z. Alternately, I could say medium is to long as medium is to long. So setting up that proportion, I would say 12 is to z as z is to that whole long side, which is 15. If I solve that, I would get z squared equals 12 times 15, which is 180. So then the square root of both sides, z equals 13.4. So z equals 13.4. To find x, I'll just apply the Pythagorean theorem. So then I would have, if I look at this triangle right there, 3 and 6. So I could say 3 squared plus 6 squared equals z squared. So solving that, you would get 9 plus 36 is z squared. So z squared is 45. When we square root that, we would get a decimal approximation of 6.7. Doing this last problem C here. Okay, so first of all, I could look at this left triangle and see that that is a 3, 4, 5 triangle. So y would have to be 4. Then I could set up the proportion of short to medium is short to medium. So that would be 3 over 4 is equal to 4 over x. So solving that, 3x equals 16. So dividing by 3, we'll get x equals 16 thirds, which is approximately 5.3 repeating. Then getting z, so if x is 5.3 repeating, then we could get z. We could either use the Pythagorean theorem, or we could use the proportions that say that medium to long is medium to long. So if we do it that way, we would get 5.3 to z is equal to z over 8.3 repeating. Okay, so then when you multiply that, you'll get z squared is equal to approximately 44.4. So square rooting that, you would get z is approximately 6.66. So that's your z value, 6.66. These problems are our 30, 60, 90 degree triangles. Okay, so doing 18, the first problems. So here's our 30, 60, 90. It looks like we have the medium and we want to find the short. So medium to short, we're going to be dividing by the square root of 3. So doing that, 20 radical 3 divided by radical 3 is going to be 20. Once I get that 20, then the long, so going from short to long, I'm going to be multiplying by 2. So 20 times 2 is 40. So I have that x is 20 and y is 40. Going to the next problem, we have a 45, 45, 90 triangle, because those angles have to be equal, and I have the leg is 2.5. So that means that going short to long, I'm going to be multiplying by radical 2, so I'll have 2.5 radical 2. Next problem, looks like again we have that 45, 45, 90 triangle. So going from long to short, we're going to be dividing by square root of 2, which means 16 radical 10 divided by radical 2. We're going to divide the radicals and get 16 radical 5. For the next problem, it looks like we're given the long in a 30, 60, 90. So going from long to short, we're going to divide by 2. So then we'll get, divide the 8 by 2, keeping them separated, we'll get 4 radical 7. Then going from short to medium, we're going to multiply by radical 3. So multiplying the radical 3's together, you would get 4 radical 21. That is 7 times 3 is 21. Next problem, here is our short, medium, and long. Okay, so we're given the medium, we want to find the short first. So medium to short, we're going to divide by radical 3. So 21 divided by the square root of 3 is going to be 21 over radical 3, which is approximately 12.12. That means that the long side will be multiplied by 2, so then we'll get 24.24. So 12.12, 24.24 approximately. For the next problem, we are given the long, and we're looking for the short. So long to short, we're dividing by 2, and we get 7.5. So x is 7.5. Then to get the medium, we'll multiply that by radical 3 and get 7.5 radical 3. Problem here, we're going from short to long in the 45, 45, 90 triangle. So short to long is going to be multiplying by radical 2. We're multiplying to make it longer. So multiplying by radical 2, 9 radical 2 times radical 2. Okay, so radical 2 times radical 2 is 2, because it's 9 radical 4, but radical 4 is equal to 2. So 9 times 2 is 18. Okay, next problem, let's see. So we're going from medium to short to find that short side x first. So we're going to divide by radical 3. So 4 radical 6 divide by radical 3 is 4 radical 2. We just divided the radical part. So 4 radical 2. That means to get the long, we'll multiply by 2. Multiply the 4 by 2, so we get 8 radical 2. 8 radical 2 for the long side. For these trig problems, we're using SOHCAHTOA. So labeling the missing sides here from the 36-degree reference angle, x is the opposite side, 12 is the adjacent. So opposite and adjacent, O and A use tangent. So tangent of 36 is equal to x over 12. When we cross multiply, we'll get 12 tangent 36 is equal to x. So x equals 8.72. For the second problem, labeling the missing sides, if this is the reference angle, okay, then we have our adjacent side and our hypotenuse. So this will be using cosine. So cosine of the angle is equal to 8 over 11. In order to find the angle with our calculator, we would do, so working backwards, we would use the inverse cosine. Cosine -1 parentheses of 8 over 11. And when we type that into the calculator, it gives us approximately 43.3 degrees. Next problem, we have our adjacent and hypotenuse. So using cosine, cosine 63 is equal to adjacent over hypotenuse, so 9 over x. Okay, so when we cross multiply here, we'll get x cosine 63 is equal to 9. So when we divide by cosine 63 to both sides, divide by cosine 63 to both sides, then the cosine 63's cancel. We get x equals 9 divided by the cosine 63. So in doing that problem, we get 10.10 approximately. For the next problem, labeling the sides, here's our missing angle. So we have opposite and adjacent. We're going to be finding the angle, so using tangent, but finding the angle working backwards. The inverse tangent of opposite over adjacent, so that's 10 over 3. Inverse tangent of 10 thirds on the calculator gives 73 degrees. Labeling missing sides here, we have the adjacent and the hypotenuse. So SOHCAHTOA, we're using cosine. We're finding the angle, so inverse cosine of adjacent over hypotenuse, 9 over 12. Typing that into the calculator for E, we'll get 41.4 degrees. Next problem, we're finding x. So, labeling the sides, we have the opposite and the hypotenuse. So we are using a sine. So sine of 58 degrees is equal to 13 over x. Okay, so when we cross multiply, we'll get x sine 58 is equal to 13. So dividing by sine 58 to both sides, we'll get x, that x equals 13 divided by sine 58. So on the calculator, 13 divided by sine 58 will give 15.3 x. For this problem, we have the adjacent and the hypotenuse. So we're using cosine. Cosine 41 is equal to adjacent over hypotenuse, x over 21. When you cross multiply, the 21 will attach to the cosine, so 21 cosine 41 is equal to x. So 21 cosine 41 on the calculator gives us 15.8. Last problem, we're finding that angle theta. So from theta's perspective, we have the opposite and the hypotenuse. We're using inverse sine to work backwards of opposite over hypotenuse, 12 over 14. So when we type that in the calculator, we'll get approximately 59.0 degrees. Answer. The concept for these problems in number 20 is that the sine and the cosine angles are complements. The word cosine literally means the complement sine. So within a given triangle, the sine and the cosine, so the complement angle would reference the same sides. So sine of 11 is equal to the cosine of 79 because 79 plus 11 equals 90. So similarly for part B, cosine of 66 equals the sine of 24 because 24 plus 66 equals 90. For part C, that would be the cosine of 2 degrees. 88 plus 2 is 90. Okay, so in these bottom problems, we're finding x. So knowing that these two angles are complements when they're going to be equal, we can add up x plus 18 plus the other angle 30 has to total up to equal 90. So in solving this equation, x plus 48 is equal to 90, and the complement of 48, x is equal to 42 degrees. For the second problem, then we could say that those two angles have to add up to equal 90. So we could say x minus 12 is one angle, plus 15 is the other angle, and that has to equal 90. So negative 12 plus 15 is 3. So x plus 3 equals 90. And taking away 3 from both sides, x equals 87. X equals 87 degrees. For the last problem, we'll have x plus x equals 90. So that would be 2x equals 90 and x equals 45. So it's only for the case when we have a 45, 45, 90 triangle that the sine and the cosine are both equal. We could see that on our chart that they both equal approximately 0.71. And thank you for watching.